Yes, student print. Alrighty. So this time we're talking about Unity, and it's about networks and connecting to the internet. So everything related to interconnecting computer and services and the actual internet, which is the world's largest network anyway, is going to be in this chapter. So the objectives for this chapter is going to be to introduce networks, to explore network hardware, so how you actually connect that up, the physical aspect of it, compare wireless and wired technology, the pros and cons of wireless and wired technology, set up a network, an actual network, and access network resources, things that are out there already. Introduce network, internet technology, how it actually works, connect to the internet with wires, connect to the internet wirelessly, explore IP addresses and domain names. So we'll talk about those things. So when you talk about a computer network, a basic computer network is a combination. No, that's fine. A basic computer network is a combination of hardware, software, cables, and signals that transport data. So the only thing that a network encompasses is having a computer connected to another place where it can send and receive data from. So if you have two computers connected together, that's a network. Even though it's small, they're networking together. If you have a standstill system that is only connected to itself and plugged into the wall for power, that's it, no internet on it, then you don't have a network. You only have a network when a computer is communicating with another device. Then it's a network. So they transport data or transport information back and forth. They allow computers to communicate with each other and other electronic devices. This is why the chances of having viruses is so slim, is when, I'll wait. No, you're fine. It is older printers that are loud. Busy, right? Ben said you too busy. No, so this is why the chances of having viruses on the system, if you don't have it connected to any network, is very slim. The only way to actually receive a virus is to actually have something that you physically add to the system, like a CD that's corrupt or a USB drive or something like that. But if it's not connected to the internet, then it doesn't have a portal in which people can hack your system or misuse it in any kind of way. And this comes up when we talk about the always-on devices, because most of the things that we use these days, we keep the internet connection on all the time. So it's always open. Sharing network hardware can reduce costs and expand access. So just think about it. If you're actually sharing, like, see this printer right here that we print to? It's actually set up on the network. So imagine if you had to have a printer installed for every single computer in the classroom. Of course, it would be more expensive. So it is less expensive to have one printer and then all 30 of the computers in the classroom being able to log into it and print to it. So it does always reduce costs, and you have access to it from far away places. Like you can be in a whole other building on campus, and if you have the printer IP address, you can install it on your computer and print to this printer all the way over here in this building because it's on the network. Sharing network software can reduce costs also too. They facilitate data sharing back and forth, and they also enable collaboration. So you'll find that people use networks to collaborate on projects a lot. Because anybody's using the new Google stuff, the Google Plus and all that kind of thing. If you're using any of those things, the Google Documents and all, they update in real time. So like if you're working on a paper and you change something on it, your friends will automatically be updated that something's been changed, so you can collaborate on projects from a long distance. So that's what networks enable you to do. The disadvantages of a network, I just kind of discussed that a second ago, that the vulnerability to unauthorized access. Once you are connected to something outside of your computer, then your computer is vulnerable. I don't care if you got firewall on it, virus protection, anything like that. Once it actually is connected to another system and it goes outside of itself, then it becomes vulnerable for any type of attacks or viruses and things like that. Vulnerable to malicious codes. Things that change your computer, take information from it, delete the whole hard drive, whatever the code is set up to do, that's what your computer becomes vulnerable to. In this book, there's 5 different main types of networks. So when you're breaking them down, the Personal area network, that's kind of like what we have when we have like a little printer at our desk. We have our smartphone, we have our computer, and we can sync everything together. We can let it talk to each other. We can save information from one place to the next using Bluetooth and stuff like that. So that's like a personal area network, just you and your devices in a small setup. Then you have the local area network. That's what you'll find mostly all jobs you go to, places you visit. Like even here in this building, we have a local area network. It's a network about the size of when the book it explains to be one building. So think about the school campus, and that the network is the local area network is about the span of one of these buildings. They each have their own wireless access points from one building to the next. Also, a neighborhood area network. That's going to be one like when you go to Starbucks or you go to like the library. They're called neighborhood area networks because you can use them as long as you are right there in the neighborhood. And you might be able to get a block away and you may still be able to use the services. And then we have metropolitan area networks. Those are going to be things that cover a large group, like say the Dallas County Community College District. There's a network that covers the whole campus that goes across, that's set up that goes across the city from one campus to the next, and we can share resources if you have access and you have permissions on the network to do so. And that's a metropolitan area network. So when we talk about a wide area network, those are going to be like your internet service providers. So like your, who's one? Time Warner, Comcast. Those are metropolitan, wide area networks because they provide services for large areas. So most of us have to start off with the wide area network, and then within that we have smaller networks because ultimately we have to get the signal from the service providers. Then we have the client-server network. So in any type of network, for the most part, not always the case, you'll have a computer that's either a server or either it acts as one. Only thing a server is something that actually is the one, the computer that's in charge. That's the easiest way to put it. Usually the one that holds, like, so if you have a print server, it's the one that holds all the information for all the printers and all their IP addresses and where they're located on the network, so that whenever you go to use a printer, it comes from your computer, goes to the print server first, and then it actually sends the correct information to the printer that you're trying to print to. So you can have different types of servers. There's email servers, and then, servers that are specifically for certain software that you use at a job, depending. Server computer provides services and resources to client computers. So all these computers in the classroom would consider to be a client, and then the main server is probably in a closet somewhere. And that's what we log into to get email, because the email software is all on the server. We log in also to go to P drive and Y drives and things like that where we store information. It's all on the server. And then there's peer-to-peer networks. We do not have a server. Whenever there's a peer-to-peer network, it's kind of like those websites like LimeWire. I think that one closed down, but like BitTorrent sites where you can share files, and they usually are illegal, so they kind of close down pretty quickly. Those are peer-to-peer. There's no computer that's in charge of any services. You're just sending and receiving data back and forth from a computer at the same exact level as the one that you're operating on. So that's why it's called peer-to-peer, like person-to-person kind of thing. So no computer that's running services or having any particular resources. It's just when you send and receive information back and forth. So then we have network devices. There's the modem that's on the computer. The modem is going to be what allows your computer to actually receive the signal from the internet service providers. And then we have a network hub. Whenever you see the word hub, that just means that it provides you with multiple connections for the same resource. So like a network hub is going to be, you can plug in one network connection cable into a box that has about 10 connections on it. So you plug it in order to kind of split the signal. That's a better word for it to me, as a splitter. But they'll call it a hub. So you can have like a USB hub the same way you can have a network hub thing, same idea. You just plug in one USB connection, and then it gives you 10 from the actual device that you plugged in. So a network hub is the same way. You plug in one main connection that comes from outside, from the internet service provider, and that little box that you plug it into, the hub, provides 10 connections for 10 other computers. And then we have network switches that actually switch the signal from one place to the next, and then routers that actually route the signal from one place to the next. Network interface card, NIC, you have to have one in order to receive any type of network connection. It requires devices to connect to a network. So it can be a wireless network card, or either it can be a wired card. And then we also have Ethernet cards. They're also called Ethernet adapters, or NICs. They support Ethernet protocols. Whenever you hear the word Ethernet, they're just talking about the cable you plug into the back of your computer that looks like a telephone cable, but it's wider and bigger. That's an Ethernet cable. Wire network, that data travels over cables, is more secure, often faster speeds. So if you think about a wireless to a wired network, wired networks are always going to be faster. Wireless networks are always going to be slower because the signal is being sent into the air, to the thin air. You can't see it. You know, those are the signals that's flying around that everybody claims is causing cancer. Other than that, you know, that's the wireless signals. It's always going to send data, and it travels a lot slower. So whenever you have a wire connection, of course, it's a direct connection. It's being conducted by wires. It's going to be much faster. And it's more secure because for somebody to breach the security in a wire connection, you have to actually have contact with that computer and that network in order to breach the security. Wireless, those signals can be intercepted, and they are all the time, by people that's looking to do something malicious. Wireless network data travels through the thin air, but the thing about wireless that everybody likes, you don't have messy wires, and it offers you mobility. You can move around. A Wi-Fi card is the same thing as a network interface card. It's just a wireless version of a NIC, what they call them. Wireless access points, that's the device that transmits and receives wireless signals. So like I said before, there's wireless signals that are on campus already, but each one of these locations have to have a wireless access point. Either they have a signal booster, which allows you to get a more clear signal in the building, or either they have a wireless access point. And all it is just like the modem you have at home with the wireless connection attached to it. And you plug it in, and then you get a wireless signal sent out from your wire connection that comes in from the internet service providers. And this here is a wireless adapter. These are kind of the older ones. I haven't seen anybody use the one right here with the antenna that snaps into the back of the computer like a PCI device in about 10 years, but they were popular at once. This is the PCI plug-in, slide-in. Most of the laptops don't even come with these options anymore, the PCI, MCI slots. And then we have the Netgear one. This looks more like the clear ones, or the ones that come from Sprint. You can purchase service, and you plug it in. It's just like a USB connection, and you can get wireless signal with it. So then we have wireless router access points that include circuitry to connect the Wi-Fi network to the internet. So like I said before, a router just allows you to send the signal to different places. That's all. Wi-Fi to wireless fidelity, most popular wireless local area network technology. So we have Wi-Fi that's out right now. We also have WiMAX. They're just two different types of ways that the signal is actually sent and received to the people that are using a wireless connection. Most of your laptops and stuff have Wi-Fi built in. Now, most recently, they're starting to come with WiMAX built in. Wireless connection nonetheless, but it's just different technologies, and WiMAX is supposed to be a much faster speed. Wireless network use, they're radio frequency signals to transmit your information. They also use microwave signals and then infrared signals too. Setting up an Ethernet network is easy to install. A wired network is very easy. I mean, if you have all you need is if you're doing this at home, I think everybody's probably, if you move the computer from one room to the next and you set up a wireless Ethernet network, all you need is the modem, the cable connection that actually comes from the wall. So you need a coax cable, then the actual modem. You plug it in, then you take the Ethernet cable, plug it into your computer. You can actually do this with other computers. If it's a modem that has more than one connection, you plug the main system up into where it's directed on the actual modem, and then you can plug other computers up to it too. Then that way you can share files, send and receive information. Now that we use the internet in a much different way, people have less of a use for setting up personal Ethernet connections at home. They don't do it as much. But because we have all of these cloud storage and all that kind of stuff, where email we use more frequently, where you could send things in thumb drives, USB drives, without having to actually set up a home Ethernet connection network. Setting up a wireless network, place wireless router in a central location, and you set up the router. The thing about it now is that most of these internet service providers provide you with modems that have routers connected to them. So The modem comes in and it also has wireless capability too, which makes sense. So you don't have two boxes anymore. You just have the one. And most of the time, they ask you if you need a password on it. Everybody's been in neighborhoods where people didn't have passwords on their wireless connection, and you can just connect to it. The problem with that is that both people are vulnerable. The person that's actually, what I'll say is quote unquote stealing the signal is vulnerable to somebody who might have just set the location up to intercept bank information and watch you while you use the internet because, you're using the unsecured network. And then you're also vulnerable to the people that leave their networks unsecure because when you're on it, other people can tap into it and do malicious things. Setting up a wireless network, a service set identifier. So you set up an SSID that broadcasts over the internet. It protects you. Activate security and create an encryption key. So that way everything you send and receive is encrypted and it's not decrypted until it makes it to its destination. We set up wireless workstations very easily. All you need is a receiver at the workstation and the wireless router with the signal being sent. So you can have all types of receivers. At home right now on my daughter's computer, I have the little thumb drive one. And I plug it into their system. That way there's no wires. They don't need, the speed is fast enough because it's within the house. And so like they don't upload video and stuff. So it works out perfectly for them to just use the internet. And you connect the internet access device. So they're saying like a receiver of some sort, some kind of device that allows you to have access. And so this is a version of all types of wired and wireless connections. The wireless connections are represented by the dots, and then the wired connections are represented by the solid blue lines. And they're just showing how you can have this set up in your house. The internet service provider, that's where you see the globe at, and it comes from the big wide area network. And then it comes in your house through the modem, and then from there to the router. Like I said before, these two devices usually come one and the same now. So you have the modem and the router all in one device. And that's a basic configuration. Windows, for the most part, automatically detects networks, and it'll tell you which ones are available. You can also click the workgroup name to access a workgroup. A workgroup is just something that's set up within a network where people that you send and receive information to, and you share files back and forth. And only people have certain privileges with the network group or even have access to it. However, you set up those access rights on that particular computer, whether it's read only or write only to the files, or either share files, send them, receive them back and forth. You can set it up any way you want. Adding computers to a wireless network. When the SSID broadcasting is turned on, you can easily find a network. So once your computer has the broadcasting turned on, it'll find a network for you, especially if you're working within Windows. Number of ways available to access shared resources on other network computers. So there's all types of ways that we can access shared resources without having to have direct contact also too. Most of the time these days we use the internet to connect to other resources. Then there's drive mapping. It assigns a drive letter to a storage device located on a network computer. So all of your devices that are set up on a network have a driver letter. So for the most part, everybody knows the A drive is for the floppy drive, and the C drive is for your main hard drive on your computer. And then after that, the network resources start assigning itself letter drives for different drives that are located on a network. On the network itself, generally those are virtual drives, meaning that they're not individual physical separate drives, but your computer maps them as separate drives so that you can store information and retrieve it in an organized fashion. There's a file sharing dialog box used to allow other network users to access files or folders on Windows computers. So when you right click on any file or folder on a Windows computer, you go to the properties, you have the options to share files and folders to specific people on the network, or either you can share files and folders to different places. You can step out. Yeah, you can share or send and receive files on the network between specific users or either to a bunch of people, depending on how you have it set up. You can also connect a printer in one of three ways. So we have next, the ways that you can connect printers on your network. Of course, we all know that we can have a direct connection. That's outside of the network. We can also do wireless printing on the network, and then we can also have it to where the printer that's set up on one specific computer gives access through the router to the other computers that are hooked up on the printer. So as long as everybody's on a network, you should be able to print to that particular printer. And this is good for home, because if you have like a laptop at home, you have like my cell phone prints too. As long as I have that printer connected to the network, but it has to be a printer with network capabilities. It just can't be one that's just plugged in. Yeah, it has to have networking capabilities, and you can plug it directly in, and everybody can print to it. And then we have network service providers, and they maintain internet backbone links and routers. So a network service provider is going to be the provider that actually sets up the infrastructure where the internet travels from one place to the next. And so when they say the backbone links and routers, that just means how the information travels from one place to the next. The internet service providers connects the computers to the internet or a network service provider. So the network service provider is much larger, and then the internet service provider is what actually allows the data to be sent and received on the network. So then we have the bandwidth that determines how fast data travels over a network. So whenever you hear somebody say bandwidth, you can shut a system down if the bandwidth is too small and too many people are trying to visit one network at one time or use resources all at one time. So usually a larger bandwidth means that you're going to have a much cleaner and faster transaction when using a network. Cable TV and DSL have broadband. When they say broadband, there's two different: broadband, narrowband. Broadband is what we hear advertised the most. It has the fastest speeds on it as far as bandwidth is related, cable TV and DSL. And then the narrowband, that's going to be like your dial-up internet access, so the internet access that comes through a telephone line. And then you have some that deal in upstream and downstream speed. They can have a large bandwidth, but the upstream, meaning things that are uploaded, and downstream, meaning things that are downloaded, how it's sent and received, it's uneven. So even though the bandwidth is large, some of them may have a larger upstream speed and then a slower downstream speed. Satellite is really common for this type of sending and receiving. So you see here there's a connecting your computer to the internet. It has where you have a network service provider router, and then you have the internet service provider. And so you have a modem that allows you to actually receive the signal, and you can send it somewhere else, and then a router and a modem for the standalone computer. And it just shows you the position of where the internet backbone is as opposed to the network service providers and the internet service providers. So it's just a hierarchy of who's in charge of what and who you pay your bill to. But this, like I always tell people, the internet and the services are always there. It's just like water. Water's free, but to actually get it plumbed into your house, plumbing done into your house, and actually have fresh water when you turn on your faucet and all, that's what you pay for. Internet is the same way. You can't just walk outside with your computer saying, "I'll catch the signals." You have to have equipment that allows your computer or your device to actually receive the signals. So that's what you're paying for. It packaged in a usable fashion for you. And then we move on to the internet technology, the TCP/IP, the protocol that regulates internet data transport. So we transport internet data back and forth. There has to be a protocol. Whenever you hear the word protocol, that means like a standard. That means like the same way that everybody does it. So like if you go to like a fast food place in Dallas on one side of town, you go to a fast food place on the other side of town, generally they'll have the same protocols. They'll have the same way that they serve you. They'll have the same size cups. They'll have the same size small, medium, large fries and all that kind of stuff. It may vary every now and then, but the protocol is pretty standard. You go to one Marshall's and buy something, you should be able to take that receipt back, and any system that is a Marshall store should be able to read your receipt and give you your money back if you want to return or exchange. So a protocol regulates everything. So on the internet, our protocol that we use is going to be IP addresses. That's the same standard code, the same way that all addresses are set up online, so that we can send and receive information in the same fashion. There's fixed internet access, there's portable internet access, and mobile internet access. So fixed internet access is going to be like your wired connections, kind of like maybe what you have here in the classroom. Then we have the portable internet access, meaning that the internet access is portable, but you still have to tap into a wireless connection that's out there. So, and you have to have the login and usernames and all that to log in. Then we have mobile access, which means that you always have access to it. It's kind of like your cell phones, that it doesn't matter where you're at, you'll have the signal no matter what, because it comes to you through the network service providers. So one of them you can take around with you no matter where you go. The other one is portable in the sense of it allows you to attach the signals that are out there already taken around. And then a fixed one means that you don't have any mobility at all. So an example of fixed would be like the classroom. An example of portable internet access would be like your laptop and going to sit in Starbucks. So it has Wi-Fi on it already, but you still have to get the signal from like Starbucks. And then mobile internet access would be like your cell phone, because no matter where you're at, it doesn't matter. You take your internet with you. And dial-up, nobody uses dial-up anymore that much here, but in rural areas, they use it a lot because it doesn't pay internet service providers to install broadband communication from one place to the next, because they can't make the money from the people that are actually going to subscribe to it. It's not feasible. It's not profitable for them to bring the services there. So a lot of people still have dial-up, not by choice, but because that's the only thing that's available. And then a lot of those areas are having satellite now too, but dial-up is cheap, and I think in a lot of places it's free. Dial-up carried over telephone call circuit. So you have to think about the internet and how it actually evolved. It's only been like 20 years since we've actually been using these services. The initial idea about internet access, if you're thinking about how can I get this into every home, the first thing that'll come to your mind is that every home mostly has telephone connections. And so the signals are first sent over the telephone connections because those were already wire connections. But quickly we found faster ways to send and receive internet connections. Voice band modems, they convert digital signals from a computer into analog signals. So. And then you have the DSL, kind of like the next phase of the whole telephone connection thing. It's high-speed digital, and it's always on. They use standard phone lines, but it's a high-speed version of standard phone line connection. And then we have cable internet connection. It's always on. Whenever you hear the word always on, it means that it's a connection you don't have to dial up and log into, because dial-up connection wasn't always on. You were charged by the minutes, and you had to log in every single time to get services. Always on is like what we have on our mobile phones. We don't turn internet off anymore. We just let it run constantly because we have that option. It uses the infrastructure of cable television services. So cable was a faster way to get a service into a home. It conducted the internet signals a lot faster than actual telephone signals. And then you didn't have that issue because the signal could be split when it came into your house. You didn't have the issue of using dial-up connection and somebody picking up the telephone and then your connection's canceled. So, yeah, it would shut it down. And so then, with cable connection, you would split the signal, so then that way you were able to use the computer and the TV at the same time. And, for a while, of course, it would slow it down, not anymore. And then satellite internet service is always on. It's high speed. It has an asymmetric internet access. Whenever you see the words asymmetric, that means that it's not the same. That means the upstream and the downstream speeds vary. Because it is wireless signal, it's the highest speed wireless signal that you can have, but it's inconsistent. And that satellite's always been inconsistent. I mean, you can have the slightest wind blowing, it'll change the upstream, downstream speeds. You can have a little rain, you'll get knocked out altogether. This is why there's a drawback to bundling satellite services, because once one thing goes out, if you have your phone bundled into it, your internet bundled into it, you can't use anything. Everything's going at one time. And satellite is real finicky in that way. And then we have fixed wireless internet service that offers internet access by broadcasting data signals over large areas. WiMAX is one. It's Ethernet compatible network standard. WiMAX is a process of, it's kind of like, it uses a lot more, it uses other network service providers and internet service providers to keep your signal consistent. So it's like normally we use like Wi-Fi. When a signal drop, the signal just drops because you're only going through one internet service provider. With WiMAX, on the other hand, is using several different towers belonging to different internet service providers. So when a signal begins to drop in one location, it automatically attaches your connection to another tower that has a higher signal. So you're more likely to have a more consistent, faster speed using a WiMAX connection. Public Wi-Fi networks, the wireless local area network that provide open internet access to the public. So like libraries will do that. Starbucks locations will do that to the public. I'm trying to think of who else provides. A lot of fast food places are all providing internet access. I was in Wendy's the other day and I just logged on with my phone while I was sitting there eating and internet access was there. So most of them are doing public Wi-Fi networks because they know that people are more likely to come to their location if they can use their computers while they eat and things like that. Wireless access protocols, they provide wireless internet access from a handheld device. So when we explore IP addresses, all an IP address is, just remember, like, it's the same thing like as a home address. No two home addresses can be the same. That's why the postal system works so well, because there's a protocol in the way that you actually set up an envelope, right? So at the top, you put the address of the street, and then you put the street name. After that, you put the city, you put a comma, you put the state, and then underneath that, you put a zip code. IP addresses are the same type of idea. All it is multi-level understandings of where you're headed on the network. If an IP address is incorrect, you're not going to get to your destination. It's not like a person who's a mail carrier that sees that you have one number off, and they're like, oh, well, I'll just go deliver it to the next door because I know this is what they meant. The computer doesn't care about what you meant when it comes to IP addresses. The way that websites and all that curtail this whole thing is purchasing IP addresses that are similar to theirs. So it's like if you're using like a domain name, which is kind of the same thing as an IP address, but it's what you actually see. So when we go to these websites, we don't see the numbers. We see things like bankofamerica.com. But behind that, they all have IP addresses. So it's kind of like where you are in those large, those cities where people are really rich and they have like, this is the so-and-so estate. So you may be able to get it delivered by putting just on your envelope the White House. But underneath that, there's a real address that the White House actually has. So the IP address is the same way. Domain names are just something that's easy to remember, but underneath that, you have IP addresses. So a lot of companies will purchase domain names and IP addresses that are similar, very close to theirs, so that way they can redirect the traffic for people that meant to go one place. But at the end of the transaction, you are still going to the correct IP address. They've just made an allowance for people that make mistakes in that way. Like if you put in youtube.com and you put one too many U's, it'll most likely redirect you to YouTube anyway. And then there's two different types of ways you can have your IP addresses set up. A static IP address, those are permanently assigned. And then dynamic, those are temporary. So static IP addresses are generally used for things like printers, because when you log into the computers, it needs to have the same address every single time. Because when you go to print, your computer doesn't need to have to find the IP address that belongs to that printer every single time. So whether you turn that printer off and on, the IP address stays the same. On all of your devices, like the things you use at home and all that, and these in this classroom, they're dynamic. Every time you turn a computer off and on, the IP address changes because it doesn't need to be permanent at all. Domain names, like I said, every domain name corresponds with a unique IP address. So it ends with an extension that indicates a top-level domain. Whenever the word top-level domain comes up, it means like .edu, that's for education, .gov, that's for government websites, .com, that's for commercial websites, things that want to sell you things, sell you products and all, retailers for the most part. .org, those are usually nonprofit organizations. So depending on the top-level domain, at the very end of that address, you can know what services that they provide and whether it's actually a government website and things like that. If you don't see .gov, it's not the government. It's something else. And domain names are generally easy to remember, and we talk about picking domain names. So you see like here it has an IP address there, 199.166.1.7, and then there's an actual name of the computer, which is not on here, but then there's an actual name of the computer. So IP addresses on the network are set up the same exact way. And this is how it actually works. So you see the computer, at your computer, you type in www.travelocity.com. It sends it to the internet service provider. It sends the word Travelocity.com to the actual domain server for that company, and what it records is the actual IP address, which is the one, that one. Imagine trying to remember all these. When the internet first came out, that's how you went to websites. You went to it by IP addresses. And of course, over time, a very short period of time, the idea came about that if people had words they can put in to remember the websites, then they will go to them much quicker. So then you're actually still being sent to this IP address, 151.193.165.126. But as you see it, it's Travelocity.com. So just like sending a letter to the White House, you're still being sent to, 1600 Pennsylvania Avenue. But as you see it on your envelope that you put on there, you just put the White House and it made it to its destination. So the talking points for this one: why pay for internet access if you can get it for free? Because it's illegal, of course. Is free internet access always legal? There's places that provide free internet access, and then there's places that, of course, you're supposed to pay for it, but people can hack into it. Data security hackers can use unprotected wireless systems to steal financial information. So when you're stealing a signal, you have to remember, too, that some people sometimes set up dummy unsecured networks so people can log into it, and then they can steal information from you. So you think that you're stealing a signal, and they're actually stealing information from you while you're using an unsecured network. Unregulated network availability rises, so it's unethical, of course, we know that. It has security breaches and then privacy issues. So there's a whole free wireline controversy, telecommunication giants versus free wireline advocates. A lot of people are saying we should get this stuff for free. Nobody should be paying for internet access because the signals are out there already. So why are we paying to have access to them? So kind of like radio, kind of like television was. So, when television went digital, you pay for it now, or you have to have a box to get the signal in your house. Radio, for the most part, is still analog signals, so you can pull up any type of device that you have that gets a radio signal, and you'll be able to listen to the radio for free. So people feel like the internet should be that way. And we talked about all these things. So this is just a summary of what we actually just went over today. So your Unit E homework is going to be, if you go back to Blackboard and you pull up I'll go back one. Hopefully it hasn't logged me out. No. Unit E homework quiz. This is going to be everything related to the stuff we went over today. This one is actually due Thursday for you all. For the online class, it's a different due date. But for you all, this one actually is due Thursday. And it's a course, just like before, 25 points. And you can use the PowerPoint or the book. Either way, I'm sure it'll be a breeze for y'all to do. Any questions about Unit E? Internet?
So we have to submit it on eCampus?
Yeah, you go here. Just like you did that quiz before. You just click begin and you actually take the quiz online. Same thing. It is a quiz. Thursday. Mm-hmm. And I hope y'all are doing SAM. You did all yours already, Vin, so. Work on SAM. You don't want to do that all at the end of the semester.
Yeah, I have to do that.
All righty. So that's all I have.